Hello everyone, welcome to this video. In this video, we will be doing a proof by induction. Before we start, we will show you the 3 steps needed to prove by induction. The first step is the base case. In many cases, this n will be equal to 1. The second step is the inductive hypothesis. This is where we assume it's true for n equals k. And the third step, we show true for the next one. In other words, for n equals k plus 1. So we have our problem here. For all integers n is greater than or equal to 7, and the inequality 3n squared is greater than 17 times n plus 10. We start with the base case, which is n equals 7. And this is our inequality. 3n squared is greater than 17n plus 10. We replace each n with a 7. We get 3 times 7 squared is greater than 17 times 7 plus 10, which is just 3 times 49, which is greater than 119 plus 10. And this is our result. 147 is greater than 129. And this is true. So that works. So we're able to go on to the next step. We assume true for n equals k. We have k is greater than or equal to 7, and the inequality 3k squared is greater than 17k plus 10. And if you notice, we just replace each n with the k. Now the third step, we must show that it's true for n equals k plus 1. We have the original from second step, 3k squared is greater than 17k plus 10. We just replace each k with a k plus 1. So we have 3 times k plus 1 squared is greater than 17 times k plus 1 plus 10. And then you just expand the k plus 1 raised to the second power, and you distribute or FOIL on the left side, and you distribute on the right side as well. You get inside the parentheses on the left, you get k squared plus 2k plus 1, which is the same k plus 1 raised to the second power. On the right side, you get 17k plus 17 plus 10. So when you distribute everything and add everything, like terms, you get 3k squared plus 6k plus 3 is greater than 17k plus 27. So this is what we should get for n equals k plus 1. So in order to arrive to that n equals k plus 1 from our last step, we must start with the assumption, which is 3k squared is greater than 17k plus 10. In order to get it to look like the n equals k plus 1, we gotta do something to either side, either the left or the right. So in this case, to make it easy, we'll start with the left side, and we'll add 6k plus 3 to both sides, which will give us 3k squared plus 6k plus 3 is greater than 17k plus 10 plus 6k plus 3, which is 3k squared plus 6k plus 3 greater than 17k plus 13 plus 6k. Note that 3k squared plus 6k plus 3 is greater than 17k plus 27. So this is what we got from n equals k plus 1 initially. But in this case, we have 3k squared plus 6k plus 3 is greater than 17k plus 13 plus 6k. How can we get this to look like this? Well, since 27 minus 14 equals 13, we can rewrite the right side. So we get 3k squared plus 6k plus 3 is greater than 17k plus 27 plus 6k minus 14. So this is what we have now. Since 27 minus 14 is 13, we're able to do that on the right side. The left side is equal to the left side of n equals k plus 1. Just as we have here, notice that the left side of the above inequality is the same as the inequality when n equals k plus 1. But the right side is not exactly the same, but it does have the original parts, and it has a leftover part, shown below. The original is 17k plus 27, and the leftover is 6k minus 14. Now, we have to make sure that the leftover part is greater than 0. And since k is greater than or equal to 7, we can say 6k minus 14, which is a leftover, is equal to 6 times 7 minus 14, which is equal to 42 minus 14, which is equal to 28, and obviously 28 is greater than 0. Therefore, 6k minus 14 is greater than 0. And if 6k minus 14 is greater than 0, then 17k plus 27 plus 6k minus 14 is greater than 17k plus 27. Therefore, we can write the following inequalities. We have 3k squared plus 6k plus 3 is greater than 17k plus 27 plus 6k minus 14. Now those two parts on the left side, that's when we distribute, that's when we FOIL out, when we start with our assumption. And then we have 17k plus 27 plus 6k minus 14 is greater than 17k plus 27, and we got that from the previous steps when we showed that 6k minus 14 is greater than 0. Therefore, we can say that 3k squared plus 6k plus 3 is greater than 17k plus 27. Therefore, it is true for n equals k plus 1, which means the inequality is true for all integers greater than or equal to 7. And we have solved the proof by induction by showing that it's true for n equals k plus 1. Thank you for watching this video. Have a blessed day.